we usually think about cities as, well, just concrete and steel, right?
Yeah.
Kind of fixed things.
Mm-hmm. Static.
Yeah, static. But what if that's um, missing something? What if they're actually incredibly dynamic?
Like they're alive.
Exactly. A constant back and forth between the people, the lifeblood, you could say, and all the infrastructure supporting them. It's a different way of looking at it, seeing cities as almost living.
It's a really powerful way to frame it, I think, and that's really what this deep dive is all about, exploring that idea, the bioelectric nature of cities.
Bioelectric nature, okay.
Yeah, we'll be digging into those sort of hidden energy flows, the interconnected systems that, make everything tick. The sources you looked at describe cities that aren't just built, they actually, pulse with energy and information, almost like they have intention.
Pulse with energy, I like that. And the material we've got really helps untack that, doesn't it? So what's the plan? How are we tackling this?
Well, first, we'll look at how cities consume and process resources, their urban metabolism, you could call it. It's surprisingly like how an organism works.
Okay, metabolism. Makes sense.
Then we'll trace the infrastructure, the power grids, communication lines, like the city's neural networks.
Right.
And of course, people are key. The human interaction bit, that's absolutely vital. We'll get into that. And finally, look at some real world examples where this is actually happening.
Okay, good roadmap. The goal is to really understand how cities are becoming these responsive, energy aware ecosystems almost.
Right.
Let's jump in. Urban metabolism. Sounds a bit technical, maybe.
It might sound it, but the core idea is quite intuitive. It's basically the sum total of all the processes, technical, social, economic, that keep a city running.
Okay.
Think about how your body uses food for energy and gets rid of waste. A city does something similar, just on a huge scale.
Right, the biology parallel. So what are the main parts of this urban metabolism then?
You can think of it in two main chunks. First, there's the technical metabolism. That's the physical stuff, the infrastructure, the flow of resources like energy, water, materials, even food coming in.
So like power plants, water pipes, delivery trucks, the tangible things.
Exactly. The wires, the pipes, the supply chains, the stuff we often take for granted.
And the second part.
That's the social metabolism. This is more about us, our behaviors, our institutions, governments, businesses, our economic activity, how we consume things, for instance, directly impacts those technical systems.
How so?
Well, take energy use. Power companies track how much electricity we all use collectively, right?
Yeah.
They use that data to manage the grid, predict demand. It's this constant feedback loop.
Okay. I see how they connect now. Our habits feed the system. So why is getting a handle on these cycles so important?
Well, it really boils down to sustainability, the
Right.
long-term health of the city. A city with, let's say, an efficient metabolism, one that uses resources wisely and minimizes waste, is just healthier, more resilient.
And the opposite.
Yeah, the opposite leads to problems. Heavy reliance on fossil fuels, poor waste management. Your sources call these metabolic disorders. Things like pollution, congestion.
Metabolic disorders for cities. That really paints a picture. So thinking this way helps us diagnose and maybe treat those problems.
That's exactly the idea. This systems view lets us see cities not just as concrete jungles, but as living systems. And we can actually monitor and improve their metabolic health.
Okay, that makes a lot of sense. So we've got the metabolism idea down. Now, what about this bioelectric fabric the source mentions? That sounds even more like a living system.
It really does, doesn't it? And the analogy holds up pretty well. The infrastructure, power grids, transport networks, communication systems, these are like the clearest signs of this bioelectric character.
How so?
Think of them as the city's nervous system and circulatory system all rolled into one, constantly moving energy and information around the urban body.
The power grid is a perfect example, I guess. All that electricity flowing everywhere.
Absolutely. You've got generation traditional plants, but also more and more renewables like solar on roofs flowing through transmission lines down to distributors right into our homes and businesses.
And it's getting smarter, you mentioned.
Yeah, that's the really interesting part now. Smart grids. They're woven with sensors, smart meters, algorithms. They allow for real-time monitoring, meaning the grid can adapt almost instantly. It senses where power is needed, adjusts flows, integrates renewables better. It makes it more efficient and much more resilient if something goes wrong. Like it has a sense of itself.
Wow, okay. And transport fits in here too. Moving people around. The lifeblood, as the source puts it.
Exactly. Roads, trains, buses, they move people, the active cells of the city, you could say. And that's changing too, isn't it? With EVs, bike shares, integrated public transport.
Right. Electrification.
Yeah, it's changing the whole rhythm of the city, reducing fossil fuel use. It's a big shift.
And then the invisible stuff, the communication networks.
The digital synapses, that's a great term from your source. Fiber optics, Wi Fi, cell towers. They're carrying this incredible flood of data.
Which is crucial for managing everything else.
Totally. Managing energy, traffic, emergency response, even just stuff in our homes. It all relies on that rapid information flow.
It really is all connected. And renewables and smart tech are sort of amplifying this whole bioelectric thing.
They really are. Renewables mean power generation is becoming more distributed, less centralized. And smart tech AI, IoT, machine learning, it's giving cities this ability to sense, predict, optimize, to become, in a way, self aware.
Okay, so we've covered the infrastructure, the stone. Let's talk about the flesh, the people. How do we fit into this bioelectric city?
Yeah, this is absolutely critical. Cities aren't just structures, right? They're co created, constantly shaped by us, our actions, our decisions, even our collective mood, you might say.
A feedback loop again. Between the buildings and the people.
Definitely. There's this constant interplay between the built environment and what the source calls social energy.
Can you give an example of that loop?
Sure. Think about simple things. You flip a light switch, you tap your transit card, you stream a movie. Each action is an interaction with the city's systems.
Right.
Now, multiply that by millions of people. All that data creates patterns, and smart systems use those patterns to optimize things, adjust traffic lights, maybe reroute a bus based on real-time demand, manage energy flow.
So without even thinking about it, our daily routines are kind of feeding information back into this system, helping it run.
Pretty much, yeah. And it goes beyond just using the infrastructure. There's this other idea of social energy.
What's that exactly?
Think about the feeling you get in a busy public square or at a festival, or even just seeing vibrant street art or community gardens. It's like an emotional electricity. It animates the place.
I get that. The buzz of a place.
Exactly. And the lack of that, alienation, inequality, that can drain the energy from a city, impacting its overall sort of vitality.
So you need both, the tech and the people. The infrastructure and that social energy.
Absolutely. A truly living city needs that constant interplay. Technology and human presence have to work together. One can't really thrive without the other.
This all sounds great in theory, but does it actually work? Are there places doing this bioelectric urbanism thing for real?
Oh, definitely. A classic example people point to is the Bo01 district in Malmö, Sweden.
Oh, one, right.
Right.
What's special about it?
Well, it was developed on old industrial land, a brownfield site, as part of Malmö really pushing towards sustainability. The big goal was for it to be powered entirely by 100% locally produced renewable energy.
Entirely. How?
Solar panels, wind turbines nearby, and they even capture waste heat for a district heating system. It's pretty integrated.
And the bioelectric part, is it just the energy tech?
No, it's more than that. The buildings have sensors to monitor energy use, sure, but the whole design encourages walking and cycling, lots of green space, fostering community. It's about technology enabling a certain lifestyle and the design supporting it. It's holistic.
So tech, planning, and people working together.
Okay. Any other example? Yeah, there's a growing movement across Europe around positive energy districts, or PEDs.
Positive energy, meaning?
Meaning these areas aim to produce more energy from renewable sources over a year than they actually consume.
Wow, actually generating a surplus.
Exactly. They do it with lots of local renewables, energy storage, super efficient buildings, and smart management systems. Often they create these little self-sufficient microgrids.
That's impressive.
And what's interesting is that many PEDs really emphasize getting the community involved. Participatory governance, local empowerment. It's not just tech imposed from above.
So Malmo, these PEDs, they show it's not just a pipe dream. This blending of energy, data, design, community,
Yeah.
it's actually achievable.
Precisely. They're demonstrating that cities can move towards being regenerative, giving back. Essentially, rather than just consuming, it's about connecting the dots.
Okay, it sounds promising, but let's be realistic. Making this happen everywhere must be tough. What are the big roadblocks?
Oh, for sure. There are definitely challenges. I mean, first off, the cost. Upgrading old infrastructure, putting in smart tech and renewables. That takes serious investment.
Especially for older cities, right?
Mm,
Retrofitting is harder than building new.
much harder. Cities with aging systems and maybe tight budgets face a huge hurdle there.
Makes sense. What else?
Then there's the tech integration itself, getting all these different smart systems, grids, transport, buildings to talk to each other reliably and securely. That's complex. Data privacy is a big concern too, obviously. And just maintaining it all.
Right, the interoperability and security challenge, not trivial. And what about people?
Yeah, the human factor, social acceptance. People resist change, especially if it affects their habits, costs them money, or feels like they're losing control. You need really good communication, education.
Uh,
People need to see the benefit.
and feel included, I suppose.
Absolutely. And related to that is the digital divide. If access to this smart infrastructure isn't fair, it could just make inequality worse. We have to be careful about that.
So, costs, tech complexity, getting people on board, ensuring fairness, quite a list. How do we overcome these? What are the strategies?
Well, your sources highlight a few key things. Governments need to step up with supportive policies, incentives for renewables, efficiency standards, funding for innovation.
So, policy is crucial.
Definitely. Public private partnerships are also important, sharing the risk and the investment. And like we said, real community engagement is non negotiable. People need to be part of shaping their city's energy future. Build trust, build ownership.
A collaborative effort, really. Looking ahead, then, what's next? What future trends should we expect in this space?
We'll likely see much deeper integration of AI and the Internet of Things. I think predictive analytics getting really good at optimizing energy used across the whole city.
Smarter and smarter systems.
Yeah. And digital twins creating virtual models of cities to test out changes before you build them. That could become standard practice.
Simulate first, then build. Makes sense.
And some people are looking at blockchain for things like secure peer to peer energy trading within local districts, decentralized energy markets.
Interesting. So, the picture is one of cities becoming increasingly intelligent, adaptive learning systems.
Exactly. Moving towards being these self regulating, genuinely bioelectric entities.
Well, this has been a really fascinating deep dive. If we had to boil it down, what's the main takeaway?
I think the core idea is that seeing cities as bioelectric systems just fundamentally changes how we understand them. We move away from this idea of static structures
Right.
and towards seeing them as dynamic organisms, living systems where the infrastructure and the people are completely intertwined, constantly interacting.
Yeah, it really highlights how everything connects the tech, the people, culture, energy, even emotions, that social energy you talked about.
And it opens up the possibility of designing cities that aren't just efficient, but maybe even empathic, responsive, vibrant places that work better for people and the planet.
And it's not science fiction. As you said, places like Malmo, these PEDs, they show it's already starting to happen.
Exactly. The bioelectric city isn't some far off dream, it's an emerging reality.
So, a final thought for you, listening. Maybe consider how your own daily routine, catching the train, turning on the lights, interacting in your neighborhood, how does that feed into the bioelectric life of your city? And what part could you play in making its future more sustainable, more resilient, more alive?